Alright, this is lesson 19 for 8th grade, and today we're talking about polygons. Now this should be a review. We're going to jump in and talk about polygons here right away. So polygons are closed plane figures with straight sides. Well, straight sides, okay, that's important. They are closed, that means there are no gaps, everything is connected, and it's a plane figure. That means it's two-dimensional. So we're talking about two-dimensional figures with straight lines that are all connected, okay? And they have the same number of sides as they do angles. So, with that definition, which of these figures is a polygon? Well, if we look at A, everything looks closed and everything, but we have a curved side. Remember, we only want straight sides. So this is gone. Letter B, everything looks straight, but we have a gap. Not everything is connected. Not everything is connected and enclosed. So B's gone. C, everything is connected, everything is straight, but we're talking about plane figures. This is three-dimensional, we only want two-dimensional. So that has to be, that leaves us with D, and let's just make sure everything checks out. Straight sides, everything's closed, it's two-dimensional. There are 1, 2, 3, 4, 5 sides, and 1, 2, 3, 4, 5 angles. Everything looks good. D would be our definition of a polygon. That happens to be a pentagon, or a type of pentagon anyway. Okay? Now, a polygon is regular if all its sides are the same length and all its angles are the same size. Excuse me. So this one says, which polygon is not regular? And we have to say, which one appears to not be regular? I was getting a lot of B for an answer because they weren't sure if these angles were all equal. They do happen to be, and all the sides are the same length. So A is regular, B is regular, C looks like it's a square. So why is D the one that's not? D is not. Those sides might be the same, but we can see this angle here and this angle here. Those are obtuse angles, and they're probably they are the same. But this one and this one, those are acute angles. So remember, the angles have to be the same size too. So D is not a regular polygon for that reason. Just because the sides are the same doesn't mean the angles are always the same. So D, not a regular polygon. Okay. This is in their book. Polygons are named by the number of sides and angles that they have. Okay? And here is sides 3 through 12. Triangle for 3-sided, quadrilateral for 4, pentagon 5, hexagon 6, heptagon 7, octagon 8, nonagon is 9, decagon is 10, hendecagon is 11, dodecagon is for 12. And a polygon with more than 12 sides may be referred to as an n-gon, with n being the number of sides. So polygon with 15 sides, a 15-gon. So it can go all the way up to whatever you want to, 105-gon if we wanted to. And the point where two sides of the polygon meet is called a vertex, or for plural vertices. So if we go back here real quick, anytime you see a point, these are called vertices, okay, where two segments meet. And one name for this polygon below is USPV. USPV. There are 7 other names. I'm not going to show all 7, but what we need to make sure happens is we go in order. We can't be skipping around. We can't go UTVS. We can't be doing that. So another one could be STVU. That would be acceptable. UVTS. That would also be acceptable. We could also take the reverse order of these, UVTS, Oh, I just did that one. Huh, I didn't even try to do that. Alright, US TV, that's another one. US TV. So we need to make sure we go around the whole thing. We can't be skipping from one side to the other like this. We can't be doing that type of thing. It's got to go around in order or this way in order. So there are 7 more of those. Just a couple examples there. Alright. 2 things we want to talk about. Congruent. Figures are congruent if they are the same shape and the same size. Basically, everything is the same in them. Yeah, they're identical basically. 2 different objects that have everything the same, angles and side lengths. If we look at these, A and D are the closest. They look like, let me back up here, they look like they could be congruent. I know it's hard to tell because A and D, they are oriented differently. I know that that's in here somewhere. Yeah, even though they don't have the same orientation, A and D are congruent, okay? So A and D are congruent because everything's the same. Angles and side lengths, if we got out of the measuring tool, we could figure that out. Okay? Now, it says figures A and C and figures C and D are not congruent because they are not the same size. Alright, so A and D, they are congruent. But they are not congruent to C and they are not congruent to B. That's basically what that's saying. However, shapes are similar because they have the same shape. So our similar ones would be A, D, and C. All of those are similar because they have the same shape, not necessarily the same size. So that's what similar means. If they have the same shape, but not the same size, they're still similar. They won't be always congruent though. So A and D, they are congruent. They are also similar, and they are also similar to C, but not congruent to C. Alright, so if we look at A and C here quickly, we could say that C is a dilation of A. That's this word right here. I told the students to think of, oh, okay, when you get your pupils dilated, think about that, because your pupils get bigger. So that's basically what that means, dilation. A and C, well, again, C is a dilation of A. Because C is larger, it's the same shape, but it's larger. So C is a dilation of A and D. Alright, and our last slide here, I just want to go over, we got the bug in here, our symbols for all this. Which triangles below appear to be similar? So if we look at A, which ones appear to be similar? Well, they have to be the same shape. And these are right triangles. So we have A, B, and C. Those are all similar. How do we write that? We have a symbol that we use for similar, and it's a little squiggly line. We would say A is similar to B, which is similar to C. So this little squiggly line, that means similar. So all these 3 are similar. B. B says which triangles appear to be congruent. Well, B looks a little bit larger than A and C, but A and C appear to be congruent even though they're oriented differently. Here is our symbol for congruent. A is congruent to C. So basically an equals sign with a squiggly above it. Alright? So this means congruent, this means similar to. Alright. That was our review on polygons, and introduce a couple new terms probably with similar, that I'm sure they've seen congruent before, and maybe dilation, which they have heard of before. That was basically it for today, and I'll put the homework on the link.